Good afternoon for those of you on the East Coast, and thank you for joining us today to learn more about the process and the products of the NERRS Science Collaborative Transfer Project Storm Stories, communicating hurricane impacts using monitoring data and visualization. Before we get started, just a few housekeeping notes. We are recording this webinar, and the recording will be housed on the NERRS Science Collaborative project page, and I will go ahead and share the link to that project page in the chat box now. We do have a tight schedule today, so we encourage you to share questions in the chat box, and we'll have time at the end of the demonstrations for questions, and we'll start with those that are in the chat box. So as you share your questions, if you also want to include a note like this is a demo question, or these might be questions for Kaitlyn, that will help. So without further ado, as the project lead for this project, I'm excited to share our project that evolved from conversations in the Southeastern Caribbean Regional Session at the NERRS and NERRA annual meeting back in 2019. While we were all discussing the need to respond to recent regional hurricanes like Hurricane Dorian, Michael, Florence, Maria, Irma, Matthew, there were a lot. And we wanted to do so by using our reserve data. And so out of that meeting came this project, Storm Stories. But before we get too far into our webinar today, I do want to give a huge thank you to our project team members and our partners from LimnoTech, who have been a huge support in the development of the products that you'll hear about today, as well as funding from the NERRS Science Collaborative. So today's webinar will provide a background on the project, information about the tools, demonstrations on how the tools will work, and then information on how to access the tools moving forward. So through this project, our goal is to communicate the value of SWMP and reserve programming to our coastal communities. And the project team has been working with reserve staff and NERRA as end user groups to design the products. And we see these end user groups as product users and code users. So we're hoping that our educators and communicators from our coastal training programs, our education programs, and NERRA can use these products as tools to communicate about storm impacts, water quality, and the value of SWMP. And that our research and SWMP staff at the reserves can also use the products as communication tools, but they've primarily expressed interest in the code that is produced from this project to help them analyze SWMP data. And the way that these templates are designed, they will allow flexibility for customization based on the reserves and the storm, because as we know, every storm is completely different. And so these products can be used to tell a story about a single storm at a single reserve, a single storm at multiple reserves, or multiple storms at a single reserve. And the outputs from this project are going to exist in PowerPoint, R, and ArcGIS online story map, which will be developed using a companion guidance document that is also a product of this project. And most importantly, we hope that this project will help improve the technical capacity of our reserves to analyze, visualize, contextualize extreme storm events, to improve illustration on how storm events impact our coastal communities and water quality, to expand the incorporation of SWMP and storm data in our reserve programming, to enhance awareness of SWMP and the various coordinated monitoring efforts of the reserves that will help improve resilience and decision-making abilities for resource managers. And hopefully it is a product that is expandable to all of the reserves across the country and transferable to different extreme weather events that we all experience. This project kicked off in October of 2020, and we've been working with end users to get feedback on what type of data and information is of interest when talking about hurricanes or storms and their recovery efforts. And so this slide summarizes the feedback that received, including information before and after storms, the recovery times of our systems, if there was any unusual or significant data, and then storm information in general, the storm surge, degree, duration, historical context. And the data that was most of interest to be analyzed was wind data, rainfall, water depth, dissolved oxygen, and salinity. And with that end user feedback, the project team used that information to develop a list of data analyses that will be available as part of the R package, including time series data, a storm parameter summary table, maps, ridgeline plots, windrows, and rate of change. And so I'm actually going to go ahead and pass controls over to Ben, who will go more into the tools that the project has developed.
Thank you, Kaitlyn. Let's see if I can move the slide over. All right, so thanks for highlighting the analyses. I think that it's worth noting up front that a lot of the work on this project was really centered around crafting those analyses. A lot of intention and collaboration went into that. But I think through the rest of the presentation, which is focused on the workflows and the tools, some of the outputs of those analyses are kind of overlooked or take a back seat to the workflow. So I just want to mention there's a wealth of knowledge, a wealth of analyses and results that gets produced throughout this process. That said, as the goal of this project was to produce this communication tool, these print and story map outputs that describe a hurricane or a large storm event at any particular research reserve. We generally leverage 4 existing tools in order to produce those outputs, or 4 different software tools. Shanna will add on to that list of 4 when we get to the story map, but for the print report, which is highlighted here on the end of this flow chart here, a little preview there, we use 4 different software packages. The user will largely interface with Excel in this process. That's where the user will work with inputs that will help drive those analysis. They'll also develop the narrative text and point to images and files that will be inserted into a print template. The analysis and the plot generation, the map generation, the engine for that effort is in R. The user really doesn't have to interact with R too much. There's just a couple of scripts that need to be executed, but there's a lot of code development that went into this project, which Kaitlyn alluded to earlier. With R, we'll also be producing a PowerPoint file that is in line with the print template that we produced for this project. So R will take inputs from the user, all the narrative text, all the files, and populate a PowerPoint template. And then the user will be able to open that raw story and modify and tweak and finalize any cosmetic changes in order to produce that finalized print story that is produced in PowerPoint or saved in PDF format, excuse me. This is a little bit more detailed overview, a figure kind of representing the overall workflow process. We like to think of this as being 2 separate workflows. There is a plot generation workflow, which goes through the 6 analyses. As I mentioned before, the user needs to set up or set variables in an Excel file, as indicated kind of in this shaded color here. That user input variable information will be read into R, where a series of functions that have been defined for this purpose will be executed, and a set of analyses, plots, maps, and figures will be generated that can be then inserted into the print generation workflow. The print generation workflow is where the user develops the narrative text surrounding the output from the analysis, describes the hurricane event. And here what we're doing is taking input data from Excel, stitching it together in R, inserting those variables into placeholders and exporting a PowerPoint file, which can then be post-processed by the user. I should mention that the plot generation workflow and the print generation workflow can both largely be executed by simply running a single script after the variable spreadsheets have been populated. So the workflow, shows some sub steps here, but really from the user perspective, there's just a couple of scripts that need to be executed. From a user perspective, this looks a little bit more like a 9-step process. The first couple of steps are setting up the workspace, your working environment. We've set up a template for that on GitHub. You'll also need to download your data. So as a new storm comes online, of course, you'll need to grab the data from the CDMO, put that in your workspace environment. And the next few steps are walking through that plot generation workflow. You'll work in the Excel files, make all your variable inputs, you'll generate your plots, you'll look at them, you might need to iterate if you see that things seem a little off or you want to focus on a different time frame or a different station. But once you get those plots produced the way you want, you'll walk into the print generation workflow, which is where you'll develop your narrative text in Excel, run a script to produce that raw PowerPoint file, which can then be processed in PDF. I'll walk through each of these steps in a little bit more detail here, give you some screen grabs, but at the end of kind of walking through the steps in a slide format, we'll go through a brief demo that shows a little bit more interactively what these steps look like. And the goal here, I think, is to maybe flood you with a little information up front, a little background, but then circle back to the demo and show you how seamless some of these tools are. Step 1 is getting your workspace template. We've set up the environment and with some basic fundamentals and placed that on GitHub. Anyone can access that directly. You don't need to have a GitHub account, but you can come to this repository and download it and set it up on your own local machine. There are a couple of key components of the file structure. Specifically, there's a data folder where all of the CDMO and other fundamental data goes. There's documentation to help support the user. There's manuals and things like that. There is an output structure that the scripts look for, and that's where all the analysis output goes. And then there's a template files directory, which is houses all of the print template and the PowerPoint and the storm story itself. I won't go into much more detail here on the workspace organization. This is here, I guess, as a resource to you if you ever need to check the recording. But I will note that in the data subdirectory of the home environment or the template workspace, there is a variable spreadsheet or a couple of variable spreadsheets. There's the storm track variables.xlsx and the storm variables.xlsx. These are 2 files that the user will interact with in order to execute all of the 6 analyses that were core to this project. The storm track variables will guide the user through developing the maps, and the storm variables will go through all the tabular and plot-based analyses. One other key note on the home environment, this is initiated as an R project environment. If that doesn't mean much to you, if you're not an R user, that's not a big deal. But essentially what that means is that there's at least one special file that's in this environment, the .r project file, that will make life easier for you if you're unfamiliar with it. It'll allow R to kind of understand the subdirectory pathways a little bit more cleanly, and it'll make life easier for you as you open up and execute the R scripts. One other element of the workspace template that we've provided is to note that the template files folder that's within the home directory, this is the location of the blank PowerPoint storm story template. So if you ever want to look at the kind of master slides that were designed for this project, that's where that lives. You can kind of understand how the placeholders fit together. If you want to get into that file, it's there for you. And then this is also the location of the text entry file for populating the narrative around that storm story. So R will read in information from that text entry file and populate that PowerPoint, inserting things into the appropriate placeholders. Step 2 is getting the data. This is relevant to the CDMO data and some other data sources, which I'll point out. The workspace template that you can download from GitHub comes loaded with data from 2015 to 2020, at least for the project team reserves, which are listed here. If you want data that's older than that, or from anything more recent, you'll need to go to the CDMO. The link is right there. The tool, fortunately, just needs the raw data from the CDMO. So if you download it in a zip format, extract it, just dump all those CV or CSV files into the data directory, and you'll be good to go. You don't need to modify anything there. And in fact, please don't. Things might break. Storm track information is also something that you may need to grab if you want to produce custom maps that show a pathway of a particular storm or compare multiple storms on a single plot. NOAA hosts best track information, so you can download the data from there and place it into the directory noted here within the workspace directory. All right, so once you have your workspace set up, you have your data, the first step is to walk through that plot generation workflow. And in step 3, you start to work with the input variable spreadsheets. I mentioned for the plot generation workflow, there's 2 of them. There's the storm variables.xlsx, which I am showing here. This is the spreadsheet that accepts inputs for all of the plots, the graphical plots, and the tabular summaries. You can see in the screenshot that there's a tab for each of the, we say 6 analyses, but there's some sub-analyses. So there's tabs for each core analysis that gets produced. In column A for each, well, I should say that the structure of each tab is identical. In column A, there's a parameter field. In column B, the user needs to enter the appropriate values. And then in column C, there's some notes that guide the user on how to input these variables. And so you can see that in this case, the inputs are things like storm start time, storm end time, the station that you want to define, data quality flags, etc. The next input spreadsheet is the storm track variable spreadsheet. It's very similar in nature to the storm variable spreadsheet. However, this one has a little bit different structure based on the data that's needed to be provided. Here, we're accepting pathways for different storm tracks. So storm tracks are the NOAA-derived data, which I mentioned above. And so if you have a shape file that you've downloaded from NOAA, we just need to have a pathway that's pointed to that specific shape. In column B, you'd provide the storm name that you want to be displayed on the map. Column C, you'd rank the plotting order, 1 through whatever number of plots or shapes or tracks you have. And then again, in column D, there's a little bit of information that will guide the user or guide the user with regards to how to input the appropriate information. You'll see that there's different tabs here. There is some sub parameters that need to be defined for the multiple storm track map. And then those 2 combined will help produce a map that has multiple storm tracks. These other 2 tabs are for plots that only produce a single, or that only display a single track. So these are essentially duplicated. Once those spreadsheets are populated, the user doesn't need to define any more variables in the R workspace environment. However, they do need to execute those scripts. I mentioned above that there's that .r project file. So if the user goes into that R project file, an RStudio session will launch. And from that RStudio session, the user can navigate to the plot generation workflow file, which is called O1 generate analysis results.r. This is a script that's shown here, and I'll highlight this in the demo as well, but you can see that there are different R lines of code that are defined, and there are a number of different SWMP R storm functions that are being called, like event time series, event time series hourly, event time series dual, that are shown here on the screen grab. All of these are functions that were really designed for this particular project. They're all housed in this SWMP R storm package that was built in collaboration with everyone on this call. And this script here just cycles through all of those analyses one by one. I should also maybe mention that to run this script, if you're unfamiliar with R, there's a couple of ways to do it, but one simple way is to open the file by clicking on it here in this pane and then hitting source, and that will run through everything. And so really that's as painful as it gets for executing the R code. Once that is, well, so pausing there again, because I've probably gone through a lot. The keys to this workflow thus far are to populate those variable spreadsheets. All of those arguments that you put in column A and B, those are inserted into R or read into R directly, and then passed as arguments into those SWMP R storm functions that were defined for this project. But really the interaction happens in Excel. And once that R file is executed, all of the output is stored into the appropriate directories that are created as part of this project as well. The output directories are nested somewhat. If we look at our workspace environment here on the left, if we click in the output, we'll see that there are folders for water quality analyses, meteorological analyses. There's a place for maps and a place for combined plots, which are where we combine the meteorological and water quality data on a single plot. And then within each one of these subfolders, there are additional folders that describe the individual analysis. And so within each one of those analysis subfolders, you have your output from the R script. So here with time series event hourly, we can see that there are plots generated for the time series analysis, which was aggregated on an hourly basis. So the 15-minute data was aggregated to hourly time series longitudinal plots. And I should also mention that the user has the ability to define which station the analysis takes place at. So you can either say, I want to look at this one particular research or station at the reserve, and so produce all the plots only for that location. Alternatively, the user can define a single reserve, and all of the plots will be cycled through and generated for the all of the stations that are active with data within that given or provided reserve. So there's a lot of, like I said earlier on, there's a lot of information, a lot of data output that gets generated here. We're certainly not showing it all, but the idea is that everything be produced in one kind of process with the R script, and then the user can kind of sort through and digest. Alternatively, the user can be very narrow if they know exactly what they want. Kind of keeping the workflow in mind, after you have that output and you've kind of gone through that wealth of information, you may decide that you want to iterate your plots, change your time frames, just fit the narrative of the overall story a little bit more neatly. And so we expect that that's something that will happen routinely as people produce the stories for their particular events. The second bullet point on here indicates that in the script, as it would cycle through all analysis, that could take, up to 10 to 15 minutes. There's a lot of data being read in, there's a lot of analyses to perform, but one of the variables in that spreadsheet allows it's called skip, and it is an input that allows the user to skip a single analysis. So the iteration process doesn't need to take up an abundance of time. You can skip through in the individual analysis in order to just run, say, hey, I want to look at precipitation bar plots again. Let's skip everything else. That is an option. So that wraps up kind of that plot generation workflow. And once you have your iteration complete, you enter what we kind of call the print generation workflow. And that first step is to open up the storm template text entry file and start defining and developing your narrative. And you'll see a similar input structure to what we showed for the analysis. In columns D and E, the user needs to enter in information. In column A, B, and C, we have variable names in the description for each input that's required. In columns F through J, there's some additional context. But for example, in row 3 here, there's a variable called text event title, which is the event title or the name of the storm event we're looking at. And so the user would need to enter in the text as they want it to appear on the print template. That text entry is in column D. There's also file names that are sometimes passed as a variable. So we'll see in row 4, there's a storm image. In this case, it looks like the user was entering in a satellite image that they pulled from NOAA. It's a .jpeg file. So the user needs to pass that file name and make sure that that particular file name, that file exists within the template images subdirectory. So this input variable spreadsheet takes both text and image files, plot files where they're relevant, and there are tabs for each individual page of the storm report, of which there are 6. The next step in the print generation workflow is to take that input file that you just created and saved, and then run the R script, which reads in that input and populates the placeholders in the template file. This is a very similar look at RStudio, except this time we're looking at a different file. Step 2, generate reserved storm story. This is the key script for the plot print generation workflow, and different code, but you can see that this script is referencing sub steps, other R scripts. And these are just populating the template page by page and so on. But if you run this simple script by hitting source, you'll take all your inputs that you've developed in Excel and populate the raw template, which we're showing here on the left. And I will pass to Amanda now, who will talk a little bit about how to post-process that and things you might need to be aware of for that.
Thanks, Ben. So I'm going to talk a bit about the print template in terms of what's in it, the general storyline, and some of the post-processing and customization needed to create a final report from a raw report. The screenshots on this slide, as Ben mentioned, on the left shows a cover page of the raw report that was generated. And in this example, we're focusing on Hurricane Matthew at the GTM reserve. And then on the right, we're showing what the final report looks like. And what's great is that they look very similar, but there are, post-processing steps that need to happen within each page. And some pages require more post-processing or customization than others. And we'll talk through that in a little bit. Something to note here at this stage in the process, you are working in PowerPoint. So any edits that you're making, you're directly working within a PowerPoint file. And you can go to the next slide, Ben. So let's just do a quick walkthrough of an example final report so you can see the content and how the general storyline works. Here's a report that the team created for Hurricane Sandy at the Delaware Reserve. On the left is page 1, the cover page that we've seen before. This includes an intro to the storm, the reserve, and swamp. Page 2 on the right introduces the NERRs, describes a little bit more about the swamp program, where data access and summary of the reserve's monitoring efforts. on page 3 here on the left, there's a section that describes the storm track, event impacts, and this is where we also begin to bring in weather data. On page 4, we start to go into more depth on the weather data and the storm impacts. And here in this particular example, we're highlighting rainfall wind speed data, and the narrative is talking about the subsequent impacts of flooding that happened for this storm and at this reserve. On page 5 of the template, on the left, we're looking at, this is where we bring in water quality data to show water quality impacts and what that might mean for ecosystem impacts. And here in this example, we're highlighting turbidity, salinity, and dissolved oxygen. And then on the final page of the template, we're providing more detail on the NERRS program, contact info for folks who want to learn more, reiterating where you can get SWMP data, a link to the reserve websites, and then also if a story map, a companion story map exists with the print template, we can provide a link here in this report. So in terms of the post-processing steps, now that we've gone through an example final report and you've seen all the elements, the types of post-processing and customization steps that happen on each page include manual formatting adjustments, refining the narrative. Once you see your story coming together, you can see ways to kind of really refine and craft your message, and you can directly make those edits in the PowerPoint. Adding additional elements that are not automated or custom, or things that you want to customize, so captions, legends, bolded text, active website links. Adding tables. There's a little bit more of a manual process to get those nicely formatted PowerPoint tables from Excel to the template. So there's a few steps to do that. And then there's an opportunity to layer on elements to enhance your story and messaging. So adding call outs and additional icons. So now I'll turn it back to Ben, where he'll share some demos with us.
All right, thanks, Amanda. I will exit out of here and hide all of my other windows and launch kind of this demo here. So I will mention that this demo I walked through 9 key steps. I don't expect that you remember them all, but the first 2 were to download the workspace template that is available on GitHub and to download all of your data for any given event that you're interested in at a given location. Let's assume for this demo that I've already done that. So I'm walking into a preset workspace that is set up already. I'm looking at Hurricane Sandy, and I am going to be focusing on the Delaware NERR. So that's the naming convention here. Hopefully this workspace looks a little bit familiar. But if not, I'll kind of highlight some of the key aspects again. There's a data folder, which shows all of the, here are the input variable sheets, which we'll get to in a moment, but there's subdirectories for the key data. There's documentation, the output, where all the analyses will go. There's the R folder, which you can see there's about 11 scripts in total, 2 of which we'll interact with directly. There's template files, which house all of the print template information. And then there's this R project file, which I mentioned before, which I'll launch in a minute here. Also take a step back and say that for the sake of this demo, we're looking at Hurricane Sandy, and I personally just kind of set a goal of recreating a precipitation bar plot. I know that Hurricane Sandy hit sometime in about October 28th. So as we go through our analyses, I'm going to try to set a precipitation or a time frame that adequately captures the precipitation leading up to and following the Hurricane Sandy at the Delaware research location. So the first step in doing that would be to open the storm variable spreadsheet, which I will launch here. There are, as I mentioned before, tabs for every individual analysis. They're the name indicates the analysis. There's also this master tab, which has a single variable, and that is the 3-digit reserve code, which will help our script pull in the appropriate data from the CDMO files. The precipitation bar plots tab is what we need to modify in order to create the appropriate bar plot with the right time frame. We'd already populated this a little bit, so there are some defaults here for some of these later variables, but we did initially look at rainfall from the 22nd of October through the 30th, but I'm not recalling exactly what the output plot looks like. So let's say we want to move this back a little bit and look at the October 15th, and let's just bump out the end of the event a little bit and say, let's look at throughout November 5th, just to expand on that time frame a little bit. So I make those changes in in Excel, and R will read those in as arguments to the precipitation bar plot function. You'll note that the text entry notes indicate that these fields should be formatted as text or general. Really, we just don't want them to be formatted as date times. That will create problems down the line. There's a third variable here called STN MET, or meteorological station. We could define the 6-digit code for that particular station that we're interested in. However, if we leave that blank, we'll get output for any active meteorological station at this reserve. So I'm going to leave that blank since I don't know offhand the specific digit code. And then there's the next argument is keep flags, which is really just data quality. The CDMO has great data quality flags, and this just allows the user to modify what's kept and what's omitted. We'll keep that the way it is for now. Flip is an option in this particular function that allows the y-axis and the x-axis to be flipped. So the standard is to have a horizontal bar plot. You could switch that to a column if you prefer. We'll just keep it default for now. Skip, I mentioned, is an option that allows the user to skip this analysis within the R script that we execute. We want to set this to false to make sure that when we go execute our code, we are actually updating our results. And in the last argument is the user units. We can switch that to SI if we want, but we'll keep it in English. Another thing to note is that this format, as I mentioned before, is similar, identical across all of the different tabs. We just have unique sets of variables, although a lot of them are similar in nature. One thing that I want to make sure I do right now is I'm only interested in running that bar plot again. So I want to make sure that skip has been set to true for all of these other functions. So just kind of scrolling through and seeing like skip looks good everywhere. This will save us about 15 minutes of processing time. So it'll allow us to get through the demo here right now. And all right, so we look good. So I'm going to make sure I have my date frame from October 15th to November 5. I'm going to hit save. And then I'm going to navigate back to my home template workspace. And now I'm going to open up that R project file, which will launch RStudio for me. Okay, so typically when it loads, it'll have a screen like this. You'll have an R console where you can enter R code. You'll have an environment pane up here in the top right. We haven't run any R code, so we don't have any variables saved in this session at least. And then down here on the bottom right, there will be a pane that shows the kind of the relative working space. So if we go back up one level, we can see our Windows structure just as we saw it in Windows File Explorer. We go back into that R folder, we can find the plot generation workflow file or script that we want to run, which is O1 generate analysis results. That will pop up here on this top pane, and we can run it a couple of ways. I'll hit source here in a moment to execute it, but I'll just highlight again that the bulk of this script is just running through one function at a time. These functions are calling the SWMP storm package, which we developed for this project. And again, they're just running through individual functions one at a time. And each of these functions is calling the appropriate tab in that variable spreadsheet. So if we hit source, we'll get some output here in the console as R does its thing. Most of this is it's just extraneous information. These are output from the shape or the geospatial analyses when it produces maps. I think I forgot to skip the maps, so that's fine. They go quickly. And then also there's this little note that there's 32 warnings. R is very, very cautious and loves to put out warnings. If you were really interested, you could run the function and see warnings. I know from experience that all of these are not problems. And you only really have a problem when it says error. If there's error, you have a problem. If it's warning, you're probably good. I know a lot of these warnings are actually just telling us, hey, you hit skip. So we're skipping the script. Or we're skipping that function. So we're all good there. But we do need to check our output. So if we minimize that, navigate into our output folder, precipitation is a meteorological variable, and we generate a bar plot. There are several that are produced, but I'm going to look at the total precipitation, which I know this is total based on the file naming convention. If we open up that file, we'll see that we have a precipitation bar plot produced from October 15th all the way to November 5. So exactly what we wanted. For this given event, we see that the bulk of the rainfall really occurred right in that 28th through 30th. So if we were interested, we could go modify this time frame and really just narrow in on the relevant time scale. But for the demo purposes, I'm happy with that output, and I'm ready to start writing my storm story. So I'm going to enter the the print generation workflow now. And the first step of the print generation workflow is to open the empty storm story template text entry file. Hopefully this should look similar again to what we showed in the slides. We have variables going down row-wise. The name and description are defined in A through C. And then in columns D and E, we need to start putting in information. Similar to the last analysis set, we've kind of already populated this with the relevant information. I mentioned we're looking at Hurricane Sandy, so we named the event accordingly, but just to show the dynamic nature of this, let's say we want to call this Hurricane Benjamin. For some unknown reason, we can do so. And let's say as we're going through, we realize that our initial illustrations of this, that we weren't displaying inches of rain, it was actually millimeters. So we'll change some of the text that will show up in the dashboards. Maybe the wind speed that we were reporting is meters per second. I should know all of these statistics, which will show up on the dashboard component of the print template, are something that can be easily grabbed from the tabular output of the analysis section. So we already know those, but we do need to add those as text into here. We also have a storm image that we want to call for the front page. This one's Sandy from NOAA. We want to make sure that the extension is correct and that file is located in the images subdirectory, which I believe this was the name of that file. So it looks like we're good. It checks out. Our script will be looking specifically in this subdirectory. So those files need to be placed there. I won't modify anything else on the front page, but I will note that on page 4, we have our bar plot. You can see the naming convention on here is bar plot daily, the meteorological station code name, and then the parameter or variable name, which was total precipitation. That is the name of the file that we just generated. in our demo. And so if we were to change the time frame, the file name would stay the same. It would just overwrite. But note that this bar plot is being referenced on page 4. But now let's say we're happy with these variables. Let's hit save. Let's back out and go into our workspace. Again, we need to open up our project file. I did not close it from my previous session, although you certainly could. But now we need to navigate into the print generation workflow file, which is O2 generate reserve storm story. We open that up. I pointed out earlier that all the R code will be up here. It's loading some dependencies. And then this particular script is relatively simple, but it is pulling, or it's referencing other subscripts that are located in this directory, and it's just executing those one at a time. You can tell by the naming convention that each of these is populating a particular page at one at a time. And we don't need to open up those files. You're more than welcome to look at them later, but really it's just reading in the variable spreadsheet, assigning each input as a variable name in R, and then assigning that variable to a placeholder in an empty template and populating each item one by one. So this one will go much faster. If we hit source, we see again, there's some output, but again, nothing that we need to be concerned about. And then we can see that the output of that script, which is complete already, you can see that the date timestamp is in line with my central time, 147. And we have a raw storm story report. So let's open that up. And we can see that those changes I made have magically appeared. Hurricane Benjamin, although we know it's Sandy, so we could go in and say, hey, that wasn't right. We're working in PowerPoint now, so we can save this file after we post-process it. And all of these changes, all these other changes have been made as well. We see on page 4, we also have this really long empty bar plot now. In reality, we'd probably want to go back and curate this to be a little bit more balanced with the right time frame. Although if there was anything interesting in the lead up, you could certainly go back as far as you want. But that file has been updated since it was referenced in the variable inputs. So I think the key takeaway I want you all to come away with is that the interaction is very, very simple, but there is a lot of data generated in the background. There's a really strong code base. We have an R package developed for this. We have these scripts that churn through all the analyses, but the hope is that the user is able to interface most heavily with Excel and subsequently produce these analyses plots that look great and are designed to fit into this template, which is also generated through our processes in a very simplified way. So I'll pause there. I think we're pretty good on time, but Amanda, I know you maybe wanted to illustrate a couple of the post-processing steps in line with what you had described before.
Sure, just a few examples. So we're talking about like in the data dashboard on the cover page, minor thing would be to just adjust the spacing. For example, looking at the rain section, that the number is a little bit high given, the one line. So just making those minor adjustments. In terms of like thinking about your messaging and what you want to highlight, for example, you want to really bring out that this is the Delaware NERRs. So you could go in and bold font, and then we won't need to do it here, but you can add caption or a photo credit to where that satellite image came from. Additional data source notes, surge data comes from a different source. Usually the National Hurricane Center reports provide that information. So that's separate from the SWMP data. So an additional data source note might be added at the bottom. right-hand corner. So small adjustments and enhancements like that.
Okay, thanks, Amanda. That largely concludes the demo for the print templates. I believe, Shanna, you were going to take over now and kind of pivot and talk more about the, the digital Esri story map solution that leverages some of the same data analyses, but takes a different shape.
Yes, I will be taking over. To confirm, are you able to see the PowerPoint slide right now?
Yes, looks good.
Okay, perfect. So I will first walk through the workflow for this story map and go through some of the basic steps that you'll want to go through if you're creating your own story map. And then I'll do a demo as well and show you what that'll actually look like when you're navigating through ArcGIS Online. So the first step in the workflow is to compile all the content and media that you'll want to incorporate into your story map. And the print template is a main piece that'll serve as the basis for your story map. But on the next slide, I'll provide a list of some other content that you may want to consider. After you compile those materials, you'll then be able to go into ArcGIS Online and access the NERRS Storm Stories group. And that's where the story map template is housed. If you don't already have access to this group, you may need to contact your IT support or somebody who has the admin credentials in ArcGIS Online so that they can give you access. But once you are in the group, you'll be able to find the template and make a copy of it and start building your own story from that template. Because you're not as space limited with the print template, you can really expand on your story, add more text, add additional images and figures, based on the needs of your story. From there, you can review what you have in your story map and then publish it for others to see. And depending on your account privileges, this last step of publishing may also require some admin support. So here I've provided a list of additional content. Like I said, the print template is a great starting point for building your story map, but you may also want to add additional photos. There are a few sections within the story map that really lends itself well for more pictures. In the weather and water quality data sections, this is a great place to add images of your stations or monitoring equipment. In the event impact section, you can show any damage that may have occurred because of the storm. And also, if you have any before and after photos, the story map has a great tool with a slider bar where you can easily flip between a before image and an after image and see that difference. You'll also have space to add additional data plots or videos. For example, if you had something from a local news channel that you wanted to incorporate, this could easily be done in the story map. And then you can also link the reader to additional tools and web pages using hyperlinks. And there's also a timeline feature that I will point out once we go through the demo, if you have specific dates or details that you want to highlight. So now, just to give you a feel for what a final story map can look like, I'll show you the story map we created from the template. It's for Hurricane Florence and the North Inlet-Winyah Bay River. So starting off is a section where you can highlight the main takeaways you want the reader to go away with, and also highlight some great images to really capture the reader's attention. And then the first section is the overview, which you can see from this top navigation bar, and you can quickly jump to any of these sections by clicking one of these titles in the navigation bar. But this overview section, allows you to just give a brief summary of the storm and also provide some quick stats about the intensity or magnitude of the storm. In the reserve section, we have space to talk about the reserve systems and show some maps of the locations. This map allows you to interact and see different levels. So you can see the stations of just one reserve and even use these buttons to zoom in on a specific station. So it's nice to be able to interact with the content in the story map. In this storm track section, we embed a web page. This is the NOAA Hurricane Tracks website. So without even leaving the story map, you can navigate this other page and learn more about the storm. Also in this section is the timeline, where you can highlight specific happenings during the duration of the storm, and also incorporate pictures. And this is the slider that I had mentioned, where you can, in this case, we have an image of what Winyah Bay looked like before the storm and after. So you can see what changes occurred. This is a place where you can add more images for the event impacts and click through those. In the weather and water quality data sections, there's also these spots for more images. We have static data plots to explore the weather and water quality, and also the capability to include some interactive maps. So this is a ArcGIS dashboard that we embedded in here. So if you wanted to give the reader a little bit more details about the, in this case, wind speed, that is also possible. And as I continue scrolling through, you'll see that the format, for the most part, stays the same. We've got another embed time of the CDMO website. The final section is about the NERRs. So we have some information about the system as a whole. And it ends with some contact information and additional links if the reader wanted to find out even more. So now I will switch over and describe the steps to create your own storm story from the online template. Once you sign into your account, if you have a NOAA ArcGIS online account, this is the homepage you'll see. You can then navigate to the groups using the top navigation bar. And this NERRS Storm Stories group should be there once you have gained access to that. The very first link in my case is the template that we'll want, but there are also some additional resources in the group. Most of these are either maps or data that are already incorporated into the template. And so you'll want to next open up the story map template in edit mode. And this will allow you to duplicate the story map. With these 3 dots, it allows you to access some more actions, and that's where you'll find the duplicate story button. This is typically a pretty quick process, but may take up to a minute. So just for efficiency, I'll just switch to this other tab where I already have a copy of the story map created. So once you have this, it is pretty simple and intuitive to use the story map framework here. It's similar to any other text editor where you can just type directly in the sections. You can copy in information from the print template, like I said, or delete out things as needed. It also gives you the freedom to change the styling of things. So if you highlight it, you get some more options to show up, more text types. You can also bold things or even add a hyperlink. If you copy in a URL, that'll be linked here for others to navigate to. One nice thing about this story map is that the paragraphs are, they're grouped in blocks, so they're easy to move around. For example, if I wanted to move this paragraph to a different section, I could just drag this group of 6 dots and move it to a different section. Same for the images, can easily be moved. So the story map is very flexible. If these sections that we created don't quite work for your story, you're free to change the name of the section, change the order. There's a lot of flexibility. And you'll need to replace out the images and maps that are in the template. Those are just for used as placeholders. For this by the numbers figure, we have a PowerPoint template that you can use so you don't have to start from scratch and recreate it. So this will be provided in the documentation. And for example, if your storm was a category 3 instead of category 2, you could just go in here quickly, change the numbers, and then save it as a new image. And then go back to your story map and bring it in. So if you hover over any of these blocks, you get more options. So I can click the 3 dots, replace the image, and then just browse for the file that I just saved. The maps work in a very similar way. These maps here are in what's called a sidecar, and it's essentially just an immersive block that brings these maps and images together in a cohesive format, and they're organized in these slides. So whenever I'm editing, I like to first duplicate what's already there just to make sure that I don't delete out something that I maybe will want later on. So I'm thinking I don't want this map and I want to replace it. So I can now delete it and choose a new map that's already saved in my content within my account. So I'll choose this map here. And then it allows me to choose the extents that I want. I'll zoom in a bit and then place it. And it pops right up here. I feel comfortable with how this looks. So now I can delete the original slide that was in the template. And I'm good to go. So I would go through section by section and make changes like these, bring in the text and media that I want. And then once I feel comfortable with the whole story map, I can then preview the entire thing. And there's a preview button in the top navigation bar. It allows you to see things from different types of devices. So this, the one that popped up was the full screen view. This is their desktop view. There's also a view for phones and tablets. So you can just confirm that things look as expected, but Esri does a really great job of making sure that all of their content and is formatted for these different device types. And then the very last step, once you're all set with your content, is to publish the story map. And so that's also right here in the top toolbar. Right now, with the account that I'm using, I have the option to publish to the entire NOAA organization. If I wanted this story map to be viewable to everyone in the public, I would first need to contact my ArcGIS administrator, and then they would be able to publish that to everybody. So that is essentially it for the demo. There are, of course, additional details as far as making edits, but that will be included in the documentation provided. So with that, I am going to bring us back to this PowerPoint and pass things off to Kaitlyn.
Great, thank you so much. And hopefully through today's demonstrations, we hope that we illustrated the use for the templates and the coding for a variety of events, you know, more than just hurricanes in the southeast. And we hope that reserves across the country can find use for these when discussing weather events, whether it's extreme rainfall or extreme wind events. You can also use the R package to quickly analyze data and facilitate discussions with the staff at your reserve. And I'm sure with hurricane season for the Southeast and the Caribbean region right around the corner, you may all be really excited to get started exploring the tools. I know Kim Cressman has already asked to see what all graphs are produced out of the package. We're making a few final tweaks as a project team and hope to have all of the resources available for use in August. So it'll be mid-hurricane season, but give us a little bit more time to get everything together, and we'll be sure to share it with you. We will share the link to the resources and the GitHub account on the NERRS Science Collaborative project page. And then once you have access to those, we encourage everyone to practice using past extreme weather events. I know that's what the project team is doing right now. We've taken hurricanes that have already happened to practice getting an idea of the time that it takes for each of us, the people on our reserve staff that we might want to engage with, to really get an idea of how we can support each other, because we recognize that if you're like me, I'm a coastal training program coordinator and I don't work daily in R, but being able to execute the R script and the package that LimnoTech has developed was relatively easy as long as I followed my checklist of things to do. And using ArcGIS online and creating a story map is also not something that I do on a regular basis, but the step-by-step instructions are definitely helpful. So you might want to pull different folks from your team depending on what post-storm looks like for you. And the idea with these is that hopefully if you have the applications on your computer and you have the guidance document, you could hopefully pass this off to anyone within your staff, whether they are part of the SWMP team or the education team or the coastal training team or stewardship, and say, hey, can you spend some time working on creating this? And it'll hopefully be a good team effort after a storm event. As far as the project is concerned, the project funding ends at the end of May, so in like 6 days. But the project team has discussed and agreed to meet again in May of 2023 to regroup for us to discuss challenges and successes. If we came up with an idea to add something to the template and we've already created a way to do that, or we have, troubleshooted through something and we, have found another way to do it, then we'll make sure that we share that through the NERRS Science Collaborative in the GitHub page. And between now and May of 2023, I will serve as the main point of contact for any troubleshooting as you begin to develop your own storm stories. And if I cannot figure out the answer, I've got a great team who will be there to help answer any questions that you all might have. And so as we wrap up with the informational and instructional portion of today's webinar, and before we enter into the Q&A portion, I just want to give another huge thank you to everyone on the project team, from the reserve staff on the project team, as well as the reserves that, whenever the project team came to you to say, hey, what do you think about this? Through all of the iterations of the products or the script or anything like that. Thank you to those of you who are always willing to give time to give that feedback. And a huge thank you to the team at LimnoTech for being with us every month on our monthly calls and getting notes and taking feedback and really setting us up for success to make sure that these tools are something that help streamline our communication efforts as we are recovering from storm events or going back and writing about historic storm events. And also a huge thank you to the NERRS Science Collaborative for funding this project. It is a great resource that we have in the reserve system. They help with everything from beginning to end. And if you haven't been a part of a NERRS Science Collaborative project, I encourage you to learn more about them. And whoops. With that, a QR code that'll take you to our project page. And we do have about 15 minutes for questions. So we'll go ahead and open the floor to questions. And there are several already in the chat box. So I'm going to start with those in the chat box. And then if time allows, then we will do the virtual raised hand question approach. All right, this question is from Rebecca. First, it's two questions. I'm sure that it is variable, but is there an estimated time it takes to go through the steps to get the PowerPoint output?
I can answer that from a processing perspective, and I might hand it off to Amanda, who can speak to the more practical side of implementing it. Once the variable spreadsheets and all of that information is kind of they're decided, it takes about 15 minutes, I think, to process all of the analyses, and then assembling the PowerPoint file is, moments, seconds. So it's really just the analysis takes about 15 minutes once the variables are characterized. I think the other things to consider are probably takes about half hour to an hour to set up the workspace environment, make sure that the R packages are loaded properly. That takes a little time, your first go around. But Amanda, I don't know if you want to speak to the workflow and how long that takes.
Yeah, I was thinking about this question, and to give like a firm number right now at this point, it's difficult just because we've been in this development process and we're just starting to get to like production. Some things, so I can't give you, a firm time frame. It's certainly not weeks. I would say, days, and that's really the difficult, or I guess the challenging, or not challenging, but the time commitment part is understanding the hurricane, looking at the data, What's great, what Ben just spoke to, is the plot generation piece is really, I think, an easy lift. You just need to know your timeframes, and you can get that data analysis super fast. But it's then looking at all the data, understanding what's going on, doing that data analysis part on your end, thinking about the story you want to tell, gathering background hurricane information, understanding the storm tracks, gathering images that we'll certainly be providing standard resources that folks can go to that are available to the public, but hopefully you also have some local images that you can use from your reserves. So, that's a little bit more time consuming, getting all of the imagery together, gathering that kind of content, and then thinking about the narrative that you want to write and the story. So that does take a little bit of time, but it's not, like I said, it's not weeks or a week. I think it's like a day to a few days. Hopefully that answers, gives some guidance.
Yeah, I agree. I think probably a couple of days, but nothing too lengthy. And then the second part of Rebecca's question, is it possible to utilize data that is not fully QA/QC'd by CDMO, that is not downloaded from CDMO, if a reserve wanted to, of course, with having a qualifier?
Good question. I think the short answer is probably not. I think the tools are definitely designed to take exactly what's exported from CDMO in the format that it's packaged up. If you were really creative and really wanted to try, it's possible that you could, back engineer that. But the tools are, depend on that CDMO structure and naming convention. So I would be very hesitant to even try.
Rebecca, I know in the past some reserves have used the real-time data to create their own, and so there might be some, if there is a savvy R user on your team, they might be able to reach out to some of the other savvy R users that have done that in the past and give some guidance.
I'll also add, in the past, so as Ben said, that the tools need the CDMO data, but I believe we've helped other reserves in writing, custom R scripts to deal with different types of data formats. So it's not that it's not possible, it's just not built within this particular tool.
Great, thank you. Another question about the code from Shannon. Does the code create the storm track map with the categories of the storm on it that were in the PowerPoint file, or is that an image that you need to mine for?
Ben, do you want to? Well, so
Sure.
the storm track map that's generated as part of the our package, we didn't show that here. It's a little bit, Ben can speak to this, less detailed. The hurricane categories are not on that, so that would be something that you'd have to layer on that that map that gets generated. The storm track map that you saw in that template was taken from the NORRA Historical Hurricane website as a screen grab. That's how. So yes, that, to answer your question, that was something that we mined for and brought in externally.
Yeah, and I'll say I think there are a couple of reasons for that. I think one is the mapping tools in R, while are advancing regularly and are getting pretty good, are still a little limited. And I think the other fundamental reason we don't have that information as part of this package is that I think on a short turnaround time, following a storm event, I don't know if NOAA releases the shape file that has that categorical information associated with it. So we pulled from a more rapidly generated repository that just shows simply the track. So the data we're referencing doesn't even have the category information. So we thought it was more dependable on the short time frame of having an event observing the data, collecting it, and then producing the story.
And I'll add, you don't have to, right? Because it's a historical hurricane website. That image, you don't have to take that image from there. And if you're trying to work on a shorter time frame, there's lots of other sources where you can find images of the storm tracks that are, readily available shortly after a storm.
I think that's what's great about the products here is that they are customizable. While LimnoTech has provided a list, or will in the guidance document be providing a list of where some of these resources are accessible. You're within your community, and if there is something that you can easily grab that might be more relevant to what you're trying to communicate within your storm story, you have the ability to do that. So while this is a template, it's really a great starting point for you all, and well, for everyone. And if you're just getting started, the resources are all right there. But once you start to get a couple of the storm stories under your belt and you feel comfortable and you know where you can grab data or maps or graphs, or for the story maps, news footage or videos like that, you can start adding a little bit more customization to your storm story. We do have some time for additional questions. If there are any folks who would like to raise your virtual hand, you're welcome to do that and come off mute and ask a question. And Greg shared a comment in the chat box about the CDMO providing a non-swamp station data upload function to the reserves and guests that does not ingest the data into the server, but does return a CDMO like QA/QC file to the operator. So if you wanted to go with that route, you could upload the data from a swamp-like monitoring station and obtain a file that would match the required format. That's great to know, Greg. Thank you.
Yeah, I just thought it was worth mentioning because we have a partner program to the north of us, the Barnegat Bay Partnership, and they set up a water quality monitoring system there that mirrors the swamp one. And we very strategically, work together to make it mirror swamp as best as they could, both in operations. But they routinely use that non-swamp upload procedure to QA/QC their data. And the whole idea is that at any given time, I can request data from them and they can request data from me, and then just immediately start working with it without having to format, work around in circles, getting them both formatted to the same. And so it might be a viable tool that if you have a non-swamp station that's not on the CDMO site for export, but you're sitting on data that you think are really valuable, I would think that there would be a way to work that format back into this tool.
Yeah, that's really interesting, Greg. And I'd have to sit and think a little bit about if there's anything that could end up being broken. But I think that, knowing that tool exists, I think is a great step to making that a viable option in the long term.
Okay. Yeah, if you need any guidance through that, just contact me and I'll try to point you in the right direction.
Yeah, thank you.
Thank you, Greg. Or if it's a storm that you lose your data sonde, unfortunately, because I know that occasionally does happen, or you have to make the decision to pull your data sondes before a storm comes, and there might be somebody who's kept their data sonde or other data logger in the water during the storm. So it's good to know. Thank you. All right. Any additional questions this afternoon or morning, depending on your time zone? Well, we will stick around for another 5 minutes, and I just want to extend appreciation for you all giving your time today to learn more about this project, for the project team for dedicating time, and for our project partners with LimnoTech for being part of this project and helping create these wonderful resources that hopefully will be helpful as we start communicating about storms and other extreme weather events within the reserve system moving forward.